Good morning, everyone. Today we'll be learning about biomechanics. The brief introduction about biomechanics. Bio is nothing but human body, whereas mechanics is nothing but application of mechanical laws to the human body. That is known as simpler terms of biomechanics. These are the contents we'll be brushing up one by one. The first one, human movements. As you can see in the video, a person, consider it as a robot is moving from one point to another point. Consider from point A to point B. As you can see that the movement is not smooth nor efficient. Whereas when I ask someone, that is you, to walk from point A to point B, will you be walking in the same way as the robot is walking? No. You'll be walking in a smooth, efficient, fluent way, in a sequential manner. Now, this happens because all your joints are connected to brain by the nervous system. Thus, humans can produce infinite varieties of posture and movement which require body structure to generate and respond to forces that either produce or control the body movement at various joints. Now, these motions or movement are very complex when you compare it to a robot. Human movements definitely involves muscular contraction and relaxation at various multiple bony segments, that is joints. Consider a punching bag now. Do you see the video or watch the video where a person or an animal is just hitting the punch bag? How is the punch bag moving? Punch bag is just moving to and fro direction. That is, the punch bag, when the punch bag is applied by an external force, the punch bag moves from static to dynamic or changes its position or alters its equilibrium. The movement of the punch bag from two in the to and fro direction, that is from point A to point B, only and solely depends on the intensity of the punch. Now, this is very important when you talk about the object. The object moves to and fro or in a single direction depending only on the amount of force applied. That is, how much newtons of force you apply, that much amount the object moves in any one direction or to and fro in our condition. In our example, it is the punch bag. Now consider a human being. What will happen if you punch a human being or your friend? Will he move to and fro? No, he will definitely not move to and fro. He might slap you back. What will happen if your father or mother punches you? Will you punch her back or him back? That is not going to happen. So, what are you going to do that time? Either you'll guard the punch or you'll sit quietly and take up the punch, right? So, we humans, unlike the object, are not meant to move to and fro or in one particular direction. We have got our brain to guard us, or either to guard us, or if you are in case paralyzed, you might just fall off. Now consider a person, let us take in a complex example. Consider a person who is throwing ball. Observe his bodily mechanism. Name one joint which is not moving in the video. I don't think there's a joint which is not moving in the video. Now, for example, he is throwing the ball. What all elements or characteristics are needed so that the ball reaches the target? The first one, the amount of force used, right? That is force in Newton. The second one can be, we are not sure, but it can be the distance of target, right? How far is the target or how nearer is the target? If the distance is very near, he need not move entire body. He might just use his hand to just throw the ball. If the distance is very set at a very high target, then he has to use the entire body in order to gain the momentum. Okay, the last one is definitely the direction of throw. Either it is straight or it is tangential. Now, the force varies in both distance of the target and the direction of the target. The intention to throw a ball is developed in the human brain, which controls the movement of the body. Entire body has to move in a fluent sequential manner in order to so that the ball reaches the target, the set distance, and even the direction. The movement vary depending on the type of bowling the performer does. That is either spinning or bouncing. Now, which do you think needs a lot of force? Definitely, bouncer ball needs a lot of force. Why is that? Because when you bounce a ball, you need to hit the ball to the ground so that it bounces back. But when you spin a ball, you don't need to hit it at the ground. You need to hit it at the leg or at the bat. That is what I assume. If you know anything, you can comment down below. Human movements are complicated and are controlled by brain. Brain sends signal to the muscle to contract and relax in order to perform both simple and complex movements. This is another chapter. We'll discuss it in the next video. Thank you so much for attending patiently.